The previous video mentioned simulation as one of the key processes in a professional design flow, and hobbyists can also use it to try out their ideas before the prototyping stage. This video gives you a flavour of what circuit simulation is all about. In it, I'm going to use a popular simulator, National Instruments Multisim, to simulate a circuit called a degenerate common emitter amplifier. We haven't studied this circuit yet, but we will later in the course. At this stage, all I want you to understand is roughly what a simulator looks like and what's involved in simulation. Once we've studied the actual circuit itself, you can refer back to this video again. Most analog simulations are based on a program called SPICE, which was created in Berkeley in the late 1960s and early 1970s. SPICE stands for Simulation Program with Integrated Circuit Emphasis. The Multisim program is easy to use and popular. However, it is quite costly, and there are some free alternative simulation programs which are also quite widely used. For example, LT SPICE from Linear Technology. I'll provide a link to some videos on how to use this at the top right of the screen. When using simulators, bear in mind that you should use them to try out circuit blocks and not generally large systems. Putting in very large circuits tends to make simulators crash. So rather like prototyping circuits, keep it simple for testing. See the video on circuit modularity for more detail about this. And so without further ado, let's have a look at what's involved in simulating a circuit with a typical simulator. Here's the interface with Multisim, and it's really pretty straightforward. This large area in the middle is where we draw our circuit, and the components that we use to put on the circuit come from these libraries up at the top left here. And the instruments we use to test it and to generate the signals for the circuit are on the right here. So these include signal generators and oscilloscopes and various other types of instruments you can use. So to build a circuit, let's use an example of a common emitter amplifier. So we can see the libraries or components up here. These are sources like batteries and signal generators. These are basic resistors, capacitors, inductors, diodes, and transistors, and op amps and digital components. So let's take a transistor. So if I click on the transistor icon, I get a list of transistors. And you can choose all sorts of different types here. There are models, as it's called, for each one of these different transistors. So you can pick a real transistor, which is meant to model one that you can buy, or you can just have a generic perfect transistor, a perfect model, which you can get from here. So let me use a perfect one just for an example. So I'll choose a BJT NPN model. Here's a little symbol there. And if I click on OK, it appears here, and I can move it around and drop it where I would like to. So I'll just drop it there by clicking. By left clicking, that drops it. And I'll just close that menu. So there's my transistor, all set up for me. So I need a resistor for the collector resistor, a resistor for the emitter, and 2 resistors for the bias. So if I go to resistors now, and I pick resistor from here are all the different values that I can pick. It doesn't really matter what values you choose actually initially, because you can change them later. So let me just pick up anything. 1K is selected, so I'll just OK that, and I'll drop that resistor there. And I can drop it as many times as I want. I'll put 4 of them in there. Let me show you another way of selecting one. If I select this one by left clicking on it and then right click, I could copy it and then paste it by right clicking again. So I can also set them up like that too. If I need to change the orientation of a component, let's take this resistor here. I can click on it, and I can either select rotate from the menus up at the top, or I can just press Ctrl R
Control R allows me to rotate it, and then I can just move it by clicking and dragging to where I want it to be. If I want to change the value of it, I can double click on it, and I could make this, for example, a 5K instead of a 1K resistor by just typing 5 in there on the keyboard. Click OK, and that has changed it to 5K. So let me rotate these resistors and set their values up, and I will just pause the recording while I'm doing that. Now, in order to get the circuit to work, I also need a power supply for it, and I can find that if I look in sources, look for power sources, and what we want is just a battery, which you can get DC power. There's your battery, or you could choose VCC and VEE as well, but DC power is what we want, so let's just choose that battery. We'll put our battery down, there we go, and just double click on it to set the value that you would like. I'll make this 10 volts, and that will be the power supply. So to wire things up in our circuit, it's fairly straightforward. All you have to do is go to one end of a component, like the bottom end of this resistor, and you'll see that the cursor changes from an arrow to a little cross. Then click on the end of the resistor, and I've now got a wire. And if I drag that wire down to the top of the transistor, I can left click again, and there's my connection there. And if I wanted to delete that wire, I can just select it and press delete on the keyboard, and it's gone. So let me just say that again. I move over the end of a component until my cursor changes to a little cross. Click once to start a wire, click again to end it. And if you want to delete it, just select it and press delete. So I'll just pause for a moment, and I'll wire up the rest of the circuit. I'll just demonstrate the last wire here. I move on to the end of my resistor, click on it to start a wire, and then if I want to change direction, I can just move in a different direction, or I can click and move in a different direction. And if I want to join a wire to a wire, I can just go down here till I end up on top of that wire, click again, and it makes a connection there. So that's my circuit wired up. But of course we needed some way of testing it, and to do that we can use the test instruments, which are on the right hand side here. Before I do that though, let me just say that all circuits must have a ground in them in order to work. And in this case we would normally put ground or 0 volts at the bottom end of the battery. That is the normal place to put it. So if I put 0 volts down here, that makes this 0, which makes the top of the battery 10 volts. So if I choose the ground from here, there's a little ground symbol, click OK. I will just drop a ground here, and I will wire it up to the circuit. Whoops. Wire it up to the circuit. I can't grab the end of it, that's a bit awkward. Let me just move it somewhere a bit easier, just because I've got 2 of them, isn't it? Okay, here we go. That makes this 0 volts down here, and all circuits must have that ground line in it that everything else is referenced to. So that completes the circuit. So the test instruments, I need a signal generator to generate my signal. So if I go over here and double click on this instrument here, here it is, and I can just drag it to where I would like it. So I will take a connection from here as an input connection. Actually I need a capacitor here, so let me just grab a smooth DC blocking capacitor here. I'll just choose a big one, it doesn't really matter what the value is. Stick it in there and wire that up to the input, wire that up to the output of the signal generator, wire the other output of the signal generator to 0 volts, and like that. Now to see what the instrument's doing, double click on it and you'll get the instrument there. So we can set this up. Let's set this up to to 1 kilohertz, and let's set the input up to 1 volt. And you'll notice here at the bottom the plus, the common and the minus correspond to the 3 connections that have been wiring that up. So that's me set up my signal generator. I'll just shut that just now. Or in fact, actually, let me leave it open because it's easier to see what's happening. And I want an oscilloscope as well. So let's click on the oscilloscope. We'll drag it down here. Again, to see what's happening, double click on it. And there's your oscilloscope. I'll just drag it out of the way. So let's connect channel 1 up to the input so that I can see what's happening, the input. So there we go, that's channel 1 connected to the input, and I'll connect channel 2 to the output of my amplifier. Just connect it in there. And these 2 connections here will be to ground. So let me just connect that one to ground, and I'll connect this one to the one I've just made. Okay, so that's my circuit all wired up and ready to go. Now to get my circuit working, what I have to do is click the big switch up at the top right hand side of the screen. So if I do that, there's my circuit running, like that. Now you can see that that's not very clear. So down here are the normal controls you'd have on an oscilloscope. There's a time base, and there is sensitivity. So you can see the input is much smaller than the output, and you can probably see it's an antiphase there, which is what we would expect. But we can't see the structure of the wave very clearly here. So if I just alter this down like that, you can now see the wave quite clearly. In fact, if I make it 1 millisecond per division, you can see that it is a 1 kilohertz wave. You can also see the output is just clipping there. And in fact, if I reduce the input size, let's say to 0.5 volt, that should stop it clipping. Let's run it again with the big switch at the top right. There you go. We're not clipping anymore. And I can change the size of the sensitivity of the scope in the normal way. And I can also I can couple it with AC and DC in the normal way, as you would with an oscilloscope. So that's how to set up a basic circuit and get it working in Multisim. Let me just reiterate to you the important points. Firstly, the library of components is up here. When you select one, all you have to do is select the one that you like and drag and drop it. If there's something you don't like, you can select it and press delete on the keyboard. It'll get rid of it. The test instruments are at the right side here. You always need a ground or earth in your circuit, as 0 volts, like that. But the rest is pretty straightforward. To wire it up, you simply go to the end of one component, click and drag it to where you want it to go, and then click again. If you don't like the wire you've put in, select it and delete it. Sometimes wires get mixed up and are not connected to where you think they are, particularly in situations like this, where there's several wires connected together in a small area. Occasionally you get things which are not correct there, so watch out for that. But you can wire up both analog and digital circuits using Multisim and try them out for yourself. It's an extremely powerful little program, and it does give fairly accurate results.